All right, so I'm just going to go through this question here so we understand some of the terms and phrases that they use in bivariate stats. So you can see here that I've already entered the data into my calculator. So your x value is going to be in L1 and your y value is going to be in L2. So you have your independent and dependent variable here. And so if we look at the first question, it says use your calculator, your graphic display calculator, to write down the Pearson's product moment correlation coefficient R between x and t. So essentially what it's asking you is, once you've entered this data, you can click on Stat, go to Calc, and run linear regression. And this is going to give you your linear regression line and your R value. So here I can see my R value isn't showing, so I might have to adjust my mode. And if I scroll down to my mode, I notice that my diagnostic is off, so I have to turn it on. So if you don't see your R value, make sure you go to mode and turn that off, or turn this on down in the menu. So I'm going to get out of here, go back to Stat, Calc, linreg. There's my L1, L2. Frequency list is blank. And when I run this, I have my R value, which is 0.977. So we're going to put this down as 3 significant figures. And we can see we have this linear regression line, y is equal to ax plus b. So I'm just going to write that down as well. Let's see. I'm just going to write it up here. Y is equal to 0.129, 0.129x plus my b is plus 6.82. Now we have this in terms of y and x, but of course, really this is in terms of the cricket's chirp rate and the temperature. So we could really evaluate this so that these letters are more linked with what we have here. So for example, instead of y, we could have temperature is equal to 0.129. Instead of x, we can call maybe this c as in chirp plus 6.82. So we can change this equation if we want to. The letters don't matter. It's just the calculator outputs it as x and y. All right. So if we look in the second part, we have 1b, interpret the relationship between x and t using your value of r. So we can see the value is 0.977, so it's very strong correlation. And this value is positive, so we have a very strong positive correlation between x and t. All right, so that's kind of what they're looking for. So if we look at our mark scheme here, very strong or strong positive correlation, and you get your 2 points for this, A1, A1. So those are the keywords they're looking for in this question here, okay? Next, it says, use your graphic display calculator to write down the equation of the regression line t on x, given the equation in the form t is equal to ax plus b. So that's essentially what I've done here already. I have t is equal to, but they want to see an x, they don't want to see a c. So we should write t is equal to a, which is our 0.129 x, and then plus our b is plus 6.82. So at any point, this regression line models this temperature depending on the number of chirps. So if a cricket chirp rate is at 10, then we can insert 10 for a value of x, and we can find the temperature. So we have to make sure we understand that the relationship between temperature and the cricket's chirp rate. Next, calculate the air temperature when the cricket's chirp rate is 70. So this is what they're getting you to do. So what you should do is fill in your value here for your method marks. 129. Our x is the chirp rate, so they tell us it's 70. And then we have plus 6.82. So if we pull up our calculator here, and we do that quickly, we have 0.129 times 70 equals and plus 6.822, and we get 15.85. All right, so equals to 15.85. Now the IB accepts non-rounded complete answers. So in this case, we don't have decimals running after the 5, so we can write this as 15.885. You should be able to write it as 15.9 as well if you round to 3 significant figures. So if we look at our mark scheme, just to make sure we have all the right marks, we scroll down here. We have, first of all, our formula there that they asked us to write down, which is correct in the previous step. And now you get your method mark for writing into 70 into the formula, which we've done here. They have another method, but we use this method one here. And then if you look at our answers, they accept 15.9 or 15.85. So far, everything's looking good with our values. Now in this question, they've asked us to write down or draw the regression line, but previous in the question, they did not ask us to create a scatter plot. So in 1E, we cannot do this unless we make a scatter plot of this data, but they have not asked us to do this. But normally what we want to do when we do draw a regression line is make sure it goes through our mean X bar and our mean Y bar, in this case temperature. So if we were going to find out the other value, and we did have to draw the regression line, we would have to go to Stat, Calc, and 2 variable stats. And this will give us all the statistics on our L1 data value and our L2 data value. So if you see this here, you can see that our X bar is 70, which is exactly what they've given us. And if we scroll down, we can find our mean value for Y. And so when we want to draw the regression line, we can draw it through the point. And you can mark this down for method marks here too. 70, comma, it is 15.85. So 15.85. And as you can see, this is the air temperature actually for a cricket's chirp at a rate of 70. So we've actually found Y bar in the previous step, okay? All right, if we look at part F, we have a forest ranger uses her own formula for estimating the air temperature. She counts the number of chirps in 15 seconds, Z, multiplies this number by 0.45, and then she adds 10. Write down the formula that the ranger uses for estimating the temperature T. So this is a bit of a strange question, but it's very simple to do. Her formula is temperature is equal to the number of chirps in 15 seconds, Z, multiplies, she counts the number of chirps in 15 seconds, Z, multiplies this number by 0.045. So 0.45 times Z, and then she adds 10. So what she's doing is she's making her own relationship between the number of chirps and the temperature. So this is how she does it, right? She counts the number of chirps in 15 seconds, multiplies this number by 0.45, and then she adds 10. So that's how we get this number or this equation here. And that's what they're asking you to do. So one last additional piece to this question is calculate the estimate for the temperature using the forest ranger's formula. So it says here a cricket makes 20 chirps in 15 seconds. So if we go ahead and look at the top here, we have the chirp rate X of a cricket and the corresponding air temperature. So it's the same idea here. Now all we have is our formula, which is temperature is equal to 0.45 times by the quantity of chirps, which is 20, plus 10. So if we use the calculator to figure this out here, We can do that just by going out here. So we have 0.45 times 20, and then we have to add 10. So we have a temperature of 19 degrees, okay? And if we look at the mark scheme here, it says here we have 19 degrees. Now, in this question, we have the percentage error later on, and we don't study this in the course. This is from an AI question, so you don't have to worry about that. So there's just a simple question on using the calculator to do 2var stats and finding your R value and turning your diagnostic on in case it doesn't appear.